All right, the fun stuff. So I drove around Norman, drove around my neighborhood. I collected over 10 gigabytes of raw ADC data and video data to go with it, and includes the logs, so you can actually pull them up and see all the sync data and what you're actually looking at. So you want to see the response of a person walking a dog, it's easy enough to pull up now. So locations included neighborhoods, local city streets, country roads, parking lots, objects that you could try and classify: pedestrian, cars, animal signs, potholes, whatever you saw in the video, it's going to be there in the radar. Oh, here's an example of what a downrange plot. Every single slow time chirp is plotted, you can see that there's something a certain distance away from you, but if it was to the left, to the right, that it's ambiguous. But this is when you want to use velocity estimation, which is what gets you these nice 2D plots. So in this plot, I was in the Sprouts parking lot over on Main Street. See backing out, you'll see as you whenever I start to back out, this is on a loop, but as you start to back out, you see the Doppler shift for the velocity I'm going. So you'll see it, all the objects will fall in this, it's not your zero Doppler, but it's essentially everything kind of falls in that bin as long as it's stationary. Objects that are also moving will shift wherever. A better example, when you're stationary, you can see my puppy and my partner walking, but you can see that there's something moving a certain distance. You get a bright spot from that car. Obviously, if they're not moving, it falls in that velocity bin. Further implementation of angle estimation can help resolve that, but that's a lot. I did implement some basic implementations, but you have to start worrying about, I did not get a chance to make nice focused images, which you have to really start worrying about when you're doing a 2D grid. And there are some effects from the near field that they mentioned that's also documented in TI's work. A good example, when you're changing direction, you kind of see all of your whole bin switch. So as you back out, everything kind of moves away from you, so that shifts what the perceived velocity is. This one's cool because you can see street signs show up really well. Nice metal structure, so you get a nice response from handicap signs. That was a big thing we were thinking for co-location. If you're trying to do just syncing a video, a street sign is going to have your largest return. One thing to mention, if you think, oh, well, we'll set a threshold on street signs and look at the RCS. When I was doing research, street signs actually change size depending on the posted speed limit. So if you're looking at just using RCS, you'd have to be aware of the sign and what the calculated RCS at that speed is. Something that, as I was looking more into it, that was something I didn't think about at first. Because from my perspective, they all look like the same size. So here's another sign of me coming to a stop. You get a little bit of a bright spot from the sign. Of course, as it gets more to the edge, you're not going to see it. It really falls off once you're getting outside of your extended field of view. This one's fun. Dr. Metcalf said, well, have you ever tried doing a pothole? And I said, well, I'll try. So I found in my old work parking lot, there was a lot of clutter that someone had just dropped the trailer, I guess, and ground up the road, but you're getting a lot of clutter and response up front, and then on the smooth lot, you can see where it's just pretty much empty, and then you hit that, the curb and the trees over there starts highlighting. So that was, it should be possible to detect potholes and other road debris using this. Of course, on a massive city street, it was cool to see how cars, as they pass you, you can see the two cars in the distance, and then that response. So all this data is there, will be included along with the videos. So it can be applied to the video, to the GUI. You can take it and do whatever you want with it. It will all be available. And then if you have your own inkling, that's what the whole proposed thing's for. You can go capture data, and in an hour you'll have whatever you can think of. So, in conclusion, this, with 7 years being the new standard and TI having such a massive community for this inexpensive system,